So implementation of merge sort is one of the common question asked in many data science and machine learning interviews. So in this video, I am going to implement that. So merge sort is one of the most efficient sorting algorithm. It is based on the divide and conquer strategy. Merge sort continuously cuts down a list into multiple sub-lists until each has only one item left, then merges those sublists into a sorted list. Suppose we have to sort an array A, and in this case a sub problem, that is following the divide and conquer strategy, a sub problem would be to sort a subsection of this array starting at index P, for example, and ending at index R. So that will be denoted as let's say the sub problem would be something like this: A, P to R. Oops, it's too small. Yeah. And so following this sub problem strategy, let's say if Q is the halfway point between P and R in this case, then we can split the sub array of A, P to R into two arrays, that is A, P to Q, and then A, Q plus 1 to R, something like this. Let me put it down. Yeah, so this will be another sub array, that is I'm dividing A, P to R into two arrays, A, P to Q and A, Q1 to R. Now this is the divide part of the strategy. Now the conquering part. So in the conquer part, we try to sort both the sub arrays, that is A, P to Q and A, Q plus 1 to R. If we have not yet reached the base case, we again divide both these sub arrays and try to sort them. And finally, the combined part, when the conquer step reaches the base step or the base case, and we get two sorted sub array, that is A, P to Q and A, Q plus 1 to R, for the original array of A, P to R, and then we simply combine the results by creating a sorted array of A, P to R from two sorted sub arrays of A, P to Q and A, Q1 to R. So overall, the merge sort function repeatedly divides the array into two halves until we reach a stage where we try to perform merge sort on a sub array of size 1, that is where P equal to R. Let's just start implementing them, then all this will be much more clear. And definitely for the actual implementation, the actual theory behind the merge sort, there are so many beautiful blogs in the internet, so you can just go through them. Here I'm mainly focusing on the implementation. So here my strategy is to have two functions to implement the whole merge sort. The first function merge is like a util function, and then this second function will invoke this first function on the final list to get my final sorted array. So this first function will take two arguments, left and right. So what I'm doing is my while condition will have a condition that until this whole while loop will go on until the length of any of the left or right become 0, and left or right each is a sub array or sub list. So minimum of lane left now sorting between left 0th index item and the right 0th index item, and I also need to remove the lesser item from the corresponding list. So let's just put a comment what exactly I'm doing here. if left 0 less than right. New list. So this pop will remove element at index 0 um, in the original list and return that removed item. And that's why when I'm doing left.pop0, that removed item will be added or appended to my new list because that is lesser than the right 0. So if that's the first condition, if that is not met, then else. This one is obvious that if the left is not, if the right is lesser, then I have to do the same thing with the right 0th item. Finally, from this, I return new list. Right. All right, there ends my first method, and now the actual merge sort. Len list. I don't need this. Otherwise, return me the. I need to create two different arrays and merge them with the top method here. So merge, and this is actually a recursive function. So the one is a base case, and otherwise before the base case I am executing these function recursively to break into left and right and merging them. So merge, oh yeah, it will be merge sort list. First I'm breaking the leftmost part, which will be slice, then len of the list, divide by 2. The whole thing, sorry, this 2 will be here. That's my left part, and the right part will be, this is sort. List. I have to start from this position, len list. From here, len list by 2. From here, it will go up to the end. Yeah. Okay, that should work. Let's just check with some random data. And this is my random list. Obviously, this is unsorted. And now I'm just creating a new list after sorting it. Let's run this. Yeah. So that's my sorted list starting from the -1 and ending at 1.8. So that's the implementation of merge sort. And also in this series, I'll be doing many common Python challenges or interview problems for data science. So stay tuned.